Okay guys, so there exists another algorithm. I'm not going into the detail of this algorithm or running like dry runs, but I want you to know that there exists another algorithm so that works slightly different than this KMP. So this is called as Bayer-Moore algorithm, and it claims to be faster and efficient algorithm. So it shifts the pattern along the text from left to right and compares P1 through PM, the nucleotides, with the T J plus 1 up to T and J plus M. What does that mean? So actually it takes the, since we start the loops with 0, so that's why we add this J plus 1. So J is keeping track of, or the loop which is keeping track of the positions on your string S, where we are trying to find out this pattern, or we call it as, or label it as P. So the comparison is done from right to left. So we are not comparing the first position of the pattern with the first position of the string, but we are comparing the last position in the pattern wherever it starts from. So in the beginning we just align them together, so that is the that location, the last location of the pattern wherever it corresponds to in the string, so it matches over there first, and then it moves backwards, so it starts from right to left. So as soon as the position I occurs where pi and j plus 1 they differ, the pattern is then shifted towards the right. So the number of positions the pattern can be shifted without missing an occurrence of P in T is computed using two ways. So there is two rules. One we call it as bad character rule. So wherever we find a bad character, we will take the whole pattern and move beyond that position. The other one is good suffix rule. So within the pattern, we try to find out the suffixes. If you remember, suffix is the last part of something, and prefix is the first part of something. I guess Urdu में वो साबका और लाहका इस तरह के concepts थे, if you guys remember that. There is a bad character rule, so patterns can be shifted to rightmost occurrence of symbol tj plus 1 in the pattern, and then in a good suffix, as we have seen, that pattern can, as we have discussed, that pattern can be shifted to next occurrence of suffix pi plus 1 to pm in P. Let's look into it here, and then you will understand that what I'm saying. So we have a text T or string S, and we are comparing this with P, which is our pattern. So within the pattern, we see that this, if we start from this right hand side and start moving back, so we observe that AB is there. So that is the suffix which we are taking, the last part of it. And this suffix exists within the pattern here also. So how many occurrences, so the first part which it does is it processes the pattern first, somewhat similar to the prefix function in KMP, and tries to find out the longest suffix which is kind of duplicated or triplicated within the pattern, and it's how many occurrences it has, and then it stores there that information the way it's stored, something like in the prefix function. So that is we have this suffix and we compare them and we find the match. So first it compared this B here, and then it compares it A, and then we get a mismatch at this position. So what it does, so now it has two options. One is where it has seen the match, the mismatch, as we have seen in the previous slide. So we have a mismatch over here at this position. So where is the next occurrence of this element over here? So it starts scanning and then it finds it's right here. So it tries to align these two characters. So that thing is called as a bad character rule. So it gives its how many shifts it needed in order so that these two things they get correspond. So it shifts the pattern for next comparison according to bad character rule here. So it will shift for 5 more characters. So in that way we can align that bad character with this pattern. If it does not exist, it will move it even beyond that. This move is the shift is according to good suffix. So we have seen that this suffix already existed. First, if you remember, it compared these two folks with one another. And now, since this guy is duplicated over here, so it will align to its next occurrence. So that kind of move is called as the shift according to good suffix rule. So in this way, whether bad character or good suffix, we save some time and we save some energy. Like everybody has a bad day, so this algorithm also has some drawbacks. So if some special conditions they occur, sometimes it might achieve a linear complexity. That is the worst case scenarios. But these two kind of those movements, like with bad character and with the good suffix, it is believed to be efficient than KMP. Though it is clear is significantly faster and efficient string searching algorithm as per their claims.